Alright, we've talked about lists. I'm not sure how much more we need to talk about them. They're so similar to strings. I can think of some things that we need to talk about regarding lists. There are some useful functions with lists. If I recall, what we did is we were adding items to the list, then we popped items off, and we learned about delete, which lets you delete an item from the list. Let's make sure we know that pretty quickly, and then we're going to continue from there. So let's make a list. I'm fond of capital L. I mean my list if I'm just demonstrating something at random. Let's put some numbers into it because numbers are fun. Did I forget something? I am so sorry, pardon me.
I always use a square bracket.
You're correct. Notice this may not be a syntax error. There are different kinds of lists, which one of them I'm never planning on talking about, but let's go ahead and look at it. October12.py. So it did do something. I believe that makes a set, not a list. So let's print the list out. It prints it out. Now let's try to add something to it.
That was the wrong order.
Yeah, it's the wrong order because a set is an unordered set of values. Let's add something to our list. Add another 12 to it and print it again. We're going to see that the list looks exactly the same. There we go. So you see a set has no real order. Looks like it's sorted by increasing value, which I didn't quite realize was the case. But it's a list with no duplicates. So if I added 12 to it again, as I did here, it doesn't show up. I should not say. It's a set with no duplicates.
It doesn't repeat that number, right? Because you had 12 in the original.
Correct. I added 12 to it. It already had a 12.
Right.
So I couldn't add anything else to it. If I change that to something that's not in the list, like, 1200, whatever, then that new number will show up. Like that. And now it's not in you can't depend upon the order of a list. Of a set. However, you can still do things like print the maximum value of the set, I believe. I'm going to pretty much erase all this stuff because I don't really care about sets nearly as much as lists at this point. I can't say I've ever used a set, to be honest, in my own programming. But it did find the max, and I can use a min and I could use a sum as well. Our three favorite list functions. All right. Let's change this to be an honest to goodness list. So I'm going to comment that first line out, use squares, and in case y'all are wondering why I flaked out on that, it's because that's how you define arrays in C, C++, C#, and Java, is with the curly braces. An array is pretty equivalent to a list in this language. So anyways, let's type in some different numbers. All right, now I actually have a list, and it will maintain its order each time I add it, except I goofed. Yeah, interesting. That's right. It's L.append because it's a list, not a set. All right, there we go. All right, so we may as well make a few notes here, just because we went ahead and did it. Sets equals defined with curly braces. No particular order is maintained. Only one element of each value is in the set. So if you try to add a duplicate value, nothing happens. To add to a set, use .add. All right, now we already know this stuff, but lists are defined with square braces. You know, I'm never sure if something is supposed to be called a brace or a bracket. And then when I looked it up, it turns out it differs based on what country you're from. Like the English use the word brace for parentheses, so I give up. All right, so lists are defined with square braces. Order is maintained, meaning that, you know, if you're adding items to the end, they are still at the end the next time you check. You have to sort them in order to, you know, change the order. To add a value, use .append. To remove the last item and return its value, what did we use? There is del, which removes an item, but it doesn't return its value at the same time. Yeah, so use .pop to get the last item. So since I just appended this here, right there, if I pop it, x is equal to list.pop, and then I print my list and that popped value, L comma x, I'm going to see that the list is now missing its last element, but it was stored in X. Yep, removed it from the list. You can see that because it's outside of the square braces. If you don't care about the value, there are other ways to delete items. So del requires you to use the del If you want to remove an item by its index value, you can use del. Oh, well, look at that. This implies that pop can accept an index number. I did not know that. I had not quite glommed onto it because that's completely different than the usage of the word pop in every other context. Let's try it. Let's pop the first value. L.pop index value 0. And hex, let's store it into X and print them out again. Print L comma X again. Alrighty, it took the first one off. That's really cool. What do you know? You know, I've gone through this page, you know, in scripting classes like 2 other semesters, and I never noticed that. Alrighty. So, that's cool. Pop X, where X is the index value. I guess if you use -1, it would take the last one off, so I'm not sure why they implemented the empty brackets version of the value, the element to be removed, or just use .pop to remove the last one. Now, where pop came from is the idea of a stack. Like if you have a stack of plates, you push something onto it. Don't type this. You push Bob onto the stack, and so Bob is sitting there. And then you push Abe onto the stack. And now Abe is sitting on top of Bob. Then you push Sam onto the stack. Now Sam is sitting on that. Then you start popping them. Pop off the list. All right, Sam's gone. We just popped him. Take off the stack. Then you pop somebody else. Abe is gone. And you are retrieving their values as you do this. And then you push somebody else on it. Tim. And Tim goes back on the stack. Like that. Now stacks are used commonly in computer science, but at a lower level than we normally, or a different level than what we're learning here. People always ask me, why would you use that? The easiest example is just the undo command. This is known as LIFO, a stack is. LIFO means last in, first out. And this isn't really important to us scripters, really. I'm not even sure there is a stack command, but you can emulate them with a list. So you saw that. We pushed Sam onto it, and then when we popped it, the first thing that came off was Sam. Then the next time we popped, we got Abe. So last in, first out. That's the way undo works, right? If I type something, blah, 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 and then I type in something else, and then I hit undo, what's going to be removed? The last thing I typed in. Okay, I'm going to have to, there, like that. And then I do it again. And then I add something else to the stack. You know, that's the way undo lists work, is with stacks. You know, elsewhere, yeah, you wouldn't use a printer stack because that would mean you would try to send your document to the printer, but then the next person who came and submitted it, they would get it first, even though they submitted it after you. You wouldn't like that. All right, that's enough about stacks. I'm going to nuke all that. You can simulate stacks, though. The idea behind a stack is a structure where you add and remove items from the same end. We already have everything we need to do that. We have the word pop for remove. I should say append, but anyways, add. And your pushes are going to be append. So for our stack, a push is equal to an append, and a pop is equal to a pop. Let's try that out. Let's make a list of names. But it's going to be an empty list. Doesn't have anything in it until we start printing. Until we start putting things on it. Let's push 3 names onto it with append. Should have just made a capital N. Names.append, Bob. Names.append, Sue. Names.append, Joe. Let's print our names list. Now we're going to pop some values off. Print names.pop. Right, that takes one of them off. Print another names.pop. Lastly, let's append somebody more. One more person. Computer scientists would call this a push. Oh, you're right. Not name append, names append. Okay. And so Tim getting added to the fun. Now let's just print out our names at this point. I would like to go and modify these 2 print statements so that instead of just the names showing up, that we say what we just did. So you see these 2 print statements with names.pop? I'm going to do this. Pop, comma, like that. And then pop, like that. Alright, so when I ran it, look what happened. Bob, Sue, and Joe. Then we did 2 pops. We popped Joe, who was the last in, first out. We popped Sue, who was the second to the last. Then we added Tim, so Tim now showed up at the last. That's the idea of a stack. And I guess the reason that Python didn't specifically add a stack is because you can do it perfectly well with a list. One more thing I want to show you while we're at it is that the print command, let's print three values. X is equal to 10, Y is equal to 20, Z is equal to 30, and then print those guys out. X, comma, Y, comma, Z. And we've seen this many times. It prints them out separated by spaces. What if you don't like spaces? What if you wish that there were, smiley faces between them? This is kind of stupid. But put SEP equals, quote, and then something. I just put a smiley face for fun. That stands for separator. Alright, so between my 10 and my 20 and my 30 are smiley faces now. What if I do this? Print X, comma, Y, comma, Z, comma, sep is equal to empty string, two quotes with nothing between it. It's going to print them squished together. That's typically how Java and other languages handle things. You have to put the spaces in by hand, so to speak, rather than the print statement doing them for you automatically. I don't think I'm going to ever ask that about this, but it's useful to know. You want to change the separator, you like commas between your items, put a comma in there and run it, and then when it prints out, they're all nicely separated by commas. And we've already learned about E and D, I hope, where you could print hello, comma, E and D is equal to nothing because I don't want to go to the next line. And then I could print out Bob. And so it's going to print out hello, Bob, without any spaces between them. Like that. In this case, I don't know how to add that space automatically. You know, I could do that. I could do this. Get that space in there. But I don't think adding SEP equals would help. But let's find out. Separator is equal to I like exclamation marks all of a sudden. This is just a test. I'm curious to see if I get any exclamation marks at all. Nah. Okay, because there's nothing to separate. These are actually two different print statements, and the separator only divvies up the items in a single print statement. A very useful function is the ability to turn a string into a list. And I believe we're getting that pretty soon. What do I mean by this? What if you read some data? Don't even type this because I'll revise it if I want to. What if you read a string that looked like that and then you wanted to turn it into a list automatically with one command? You can do that. Let's see if that's next. No, del was next. That removes a specific element like that. I just want you to remove that item. Let's go ahead and tack that onto our documentation about lists. So I'm going to go way up here into my comments about lists and say to remove an item at a specified index, use del, like del list item. Now all of a sudden I don't think you even put parentheses in it. Yeah, you don't. It's not a function. Del list item 1 would delete the second item from the list. What if you don't want to specify which one? To remove by value, you use l.remove. Take my list and remove Bob from it. Like that. That'll search the list until it finds Bob and it'll remove it.
What does it say after it says delete line 1 with the second line of the
From the list. Sorry about that. Yeah, like that. And I believe we've seen replace. We certainly did for strings. I don't think we've seen it for lists. I'm sorry, did I cover that up too fast, guys? I did a Command F for replace. It didn't successfully find one. I'm going to hit Google and try to find a list replace Python. Replace values in a list using Python. Here comes Stack Overflow to the rescue. Let me cover up our stuff for a moment. Oh yeah, right. Okay. Yes, you could write a for loop to do it. We had a list of numbers up here called L. Let's just go through it and remove all the even numbers.
Is there a built-in function or a library?
I was hoping there was. There may be a library, but there's not a built-in function. So, for... I'm just going to skip this idea entirely. So you can consider a string effectively a list of characters, but there are a few differences. You're allowed to change elements in the middle of a list, whereas you can't change elements in the middle of a string. If I went way up here and I had done this, L subscript 2 is equal to 999, that would change one of these elements. Which one?
The second list.
It would change that one because this is 0,
There's your
that's
replace.
1, that's 2. Pardon me?
So there's replace.
Yeah.
Just do that.
Yeah. But I wanted to do a find and replace all. Okay. And I can't think of a way to easily do that. Yeah, just search for it. Sorry, I'm stuck on this. I'm just kind of... Is it not just find? L.find 10, for example. Don't type this until I'm sure it works. List attribute has no find. Well, why not? Let's
Is it a value button with it?
I know there is one.
Find remove.
No way. A dot index, that's how you do it. Okay. Let's define a brand new list before we start messing with this stuff. Let's do our good old favorite colors. Red, green, blue. And we want to find the index number of green. So I'm just going to say GI for green index is equal to colors.index of the word green. And then print green found at index, comma, GI. And it found it. It was at index 1, which is that. What if we look for something that didn't exist? SI for silver is equal to colors.index silver. Now that's not in it. Silver found at index, comma, SI. Yeah, silver's not in the list at all. So what you got to do before you do something, before you actually try to do index, this is where Python is kind of slightly different than a lot of the other libraries I've used. If you call find on a list or an array or something like that in those languages, then it'll return -1 if it doesn't find it. Here, Python blows up, which is less friendly. But we could check first, right? Here's how we would check. If silver is in colors, SI is equal to colors.index. All I did is indent the next two lines. Else, colon, print, silver not found in list. All right, we're just about to write the code that's going to search and replace every value. We could just write a for loop that for x in range 0 up to the length of the list and then check every single one. But I'm going to pretend that I imagine that the dot index is faster than code that we would write. That's probably a erroneous assumption. Make another list that has duplicates in it. N for numbers. Just type some numbers, but make sure there's some duplicates. My duplicate number is going to be 12. I'm going to throw in a lot of 12s in it. So, while let's try to think of good variable names for the variable that you're searching for and the variable that you're replacing it with. What would be a good variable name for something that you're searching for? Could just use search.
Or we could use a parse.
Pardon me?
Just use a S and a R.
Yeah, we could use S and R. How about sval for our search value? We're going to look for 12, and rval is going to be our replacement value, and we want to replace every 12 with a 1,000. That'll kind of jump out at us. So while sval is in our list, the index value or the search index or something like that is equal to list.index of sval. We say, hey, go and find that value for us, and then we can replace it with our new value. In at that specific index, so in square brace index is equal to our replacement val. And then let's print out our numbers. We probably should have printed them out beforehand as well, hey, but that should do it. Yep, and all my 12s were replaced with 1,000s. What would be nifty slick is to write that as a method. Excuse me, a function. So you wouldn't have to rewrite that every single time you needed to do it. So let's do that. Let's write a function, def, called replace, which takes three things. A list, an sval, search value, and an rval, a replacement value. Then it's just the same code, and I'm real tempted to change that L to an N just so I could copy and paste. But let's rough it. while the search value is in our list, the index is equal to L dot index of our search value. Just go and look for it. And then in index is equal to our new search val. So now I can call my replace function like this. I want to replace in my list called in. Remember, my list was called in.
Does the R value have to be parentheses also?
R val I've defined there. Am I missing what you're asking?
Where it says in index, or no?
Yeah, that's wrong. This should be L index. Thanks. Thank you very much. Okay, so replace in the in list every occurrence of 1, 2, 3, just because I know I have a 1, 2, 3 in there, with, you know, a negative 999, just to make it leap out again. And then print my numbers list out one more time. It's in because that's the actual list. This is just a function, and L is only valid inside that function. And what I should do is I should cut it and push it up to the top of the code, because you tend to put your functions up at the top rather than define them, mixing them in with your code itself. That's really bad programming to do it that way. Just because Python lets you do it doesn't mean it's a good idea. But on the other hand, I hate making y'all scroll up and down and scroll up and down, you know, in order to get this. But maybe after we're done with it, we could copy it and move it up. Let's run it, make sure it works though. Alright, so the first time it ran, it replaced all the 12s with 1000s. The second time it ran, it replaced 1, 2, 3 with negative 999. And kind of the reason I wanted to demonstrate that is because you might think of some function that they don't give you, like replace. Another one I would like is remove all. Not just remove 1000 from our list, but remove all 1000s from our list. And if there isn't a remove all method given to us, we could certainly write one. Let's write a remove all function. Define remove all, and you pass in a list, and the value you're going to remove, I'm just going to call it val because we're not replacing it, while that value is in the list, remove that value. L dot remove that value. That's all you have to do. Now I'm going to call it remove all from list in the value 1000. I got tired of seeing those 1000s. And then I'm going to print my list one last time. So you might wind up writing eventually your own library of list functions. If you keep finding things that you wanted that weren't in Python itself, just move all these into another PY file. You know, call it listfunc or something like that. And then when you need this stuff, you just do import listfunc, and you can do all this stuff without having to rewrite it or copy and paste it. Let's make sure remove all worked. Yeah, it removed all the thousands from it. Now we didn't have to do that for strings, and I'm surprised that in Python they've never expanded the list functionality to support those functions in strings, because I know for a fact that we went through and replaced all the values, you know, replaced all the x's with periods or something like that in our strings. Hey, wouldn't it be neat if D2L was working now? Yeah. I'm going to have to text my C++ students telling them that we're probably not going to be having the exam today. But they need to show up anyways. But I know some students who are going to be on like TDY next week. This is a drag. Okay. So parsing lines. Parse means to dissect, to take apart, to translate. This is a bad example, but I don't care. What if we wanted to print out the day of the week from a line that starts with from? Like we're going to open a big file of email and we're going to see a lot of lines that say from such and such, and then it's going to have, you know, a day of the week. It's going to say Saturday, or it's going to have this date, January, blah, blah, blah. The split method will let us divide this line up into chunks, into a list. I don't feel like doing something that, making y'all type that. So let's just make an address. No, I don't even want an address. How about, hey, let's just make a sentence. S for sentence is equal to Mary had a little lamb and some wine to go with it. I'm taking off the last part of it just because it didn't all fit on the screen. So now I want to turn that into a list so that I can look at each word separately. That's split. So what I do is I need a list to hold all those words. I'm just going to call it words. Words is equal to S split. S dot split. And now let's print out our sentence, but on the next print, let's print out our words. Use your words. All right, here we go. I'll bring the code back up if you didn't get time to type it in. But notice the sentence says Mary had a little lamb and some wine. And then when it was turned into a list, each item is in its own element. And so we could treat this, I mean, not we could treat it as a list, it is a list. And so that's an important part of parsing data. Next week we'll do an example where we give ourselves a list of commands and then we make the turtle go nuts drawing whatever we've listed. And if we're really cool, then we'll get to the chapter about files and we'll do the same thing where we open the files. I mean, I know we're going to get to it, but I'm not sure that we're going to get to it. We only have class one day next week as far as I recall. Yeah. Split becomes real useful at a later point. I'm not sure that I can justify its existence at this point. That doesn't look good. I guess there's a file somewhere called inbox short.txt. Neat. I didn't know Trinket would let you have a file there that you could open in the other tab. Alright, so objects and values. We know that both A and B both refer to a string, but we don't know whether they refer to the same string. There's two possibilities. When you do A is equal to banana and then B is equal to banana, are they both pointing to the same address in memory? Or are they pointing to separate places in memory? Now this is an odd place to throw this little bit of information here. But you can use the is keyword. We've already been using in, I-N. But you can check to see if A is B. This seems to indicate that it's going to be so. So both A and B are pointing to the same memory address. That's just kind of an optimization Python does. So that, you know, if you had A is equal to banana, B is equal to banana, C is equal to banana, you know, all the way out through Z, it only has to have the word banana once in memory. Just like you could have one house and you could have 100 for sale signs pointing to the same house. But when you create two lists, you get two objects. That's not a good example. It's not showing the two lists.
It's gonna say
But
just
let-
gotta refresh it.
Yeah, if I refresh it, it'll work. But let's play it ourselves. We have a list called words already. Let's make another list called words 2 is equal to words. Let's see if they're the same. If words is words 2, print the same words and words 2 equal the same memory. Else colon print words and words 2 not the same memory. But on Tuesday, we already established that if you removed something from one list, it would disappear when you tried to print it out from the other. Like, let's remove the word Mary from our list. So words.remove Mary. And then now let's print out words 2. Mary should be gone from it because they are the same list. So even though we removed it using the words reference, I'll bring the code back in a minute. When we removed it from words, it looks like it's also been deleted from the words 2 list. But it's because they're not really two lists. They're just two names for the same list. And I think that if I was writing this, I might not have even mentioned the is keyword. Because it's true that they're not, oh, wait a minute. This says that they are the same memory. I thought they just got through telling us that they weren't going to be at the same memory. That's what I was expecting, and so I got puzzled by. When you create two lists, you get two objects. Okay, let's refresh it. Okay. But let's prove that if we have two separate lists with the same contents, they're not the same. So I'm just going to call this L1 for list 1. And it's going to have, like, I don't care, 1, 2, 3 in it. And then L2 is equal to also to 1, 2, and 3. And then if L1 is L2, which is the case, let's print L1 is L2. I'm not going to even add the else because I know that's the case. No, I know that's not the case. I better add the else. Sorry. Else L print L1, come on, is not L2. So what that means is that when we did this, words 2 is equal to words, it didn't create a new list. And I'm reiterating a point that we talked about on Tuesday. It's just like we had two signs pointing to the same street. It's the same street.
Copy of the original list.
Yeah. If we wanted to make a copy of the original list, we would use slicing. We would do that. That would copy the entire list of words into words 2. And then when we removed Mary from words, it would still be there in words 2. Almost time to stop. But I don't have to make time for us to upload anything into D2L. What do you know? All right, guys, let's stop there. So that's called aliasing. When you say B is equal to A and one is a list, you get an alias to the other list. Other textbooks would call it a reference. I don't mind calling it Alright gang, I guess save this, and if we remember, we'll upload this stuff on Tuesday. Lists are really important, so if this stuff isn't real clear in your brain, if it's not totally gelling yet, read the PFE and Python for Everyone, then go to your book and read about lists. Lists may be one of the most important topics, because if you go on to do computer science, you're going to be doing lists all the time. You can be sure that when you're writing a video game, everything that's on the screen is in a list. When you're playing a massive multiplayer, every player that's running around is on a list in a server, or being sent to you as a list so that they can be all drawn on the screen. I'm sure the server optimizes it so that they only send you a list of players who are actually close to you, rather than sending all 20,000 people who are playing it at the same time. But you have your MP3 player, it's got a list of songs on it. You have your contacts list, it's got a list of contacts, stuff like that. Databases are just huge lists that are then you can bring them in and bring in a subset. Please, from Mr. Database, give me every record that matches this date, March 3, 1928. And then it gives you a list of those, and you're going to have to parse all of those in order to get your date out. Lists, super important. Alrighty, let's call ourselves done. And let's email this to me. All right.